Hello, welcome to our class today. We're gonna be doing parts of a PLC. This is Robert Munyiri from Masinga Technical and Vocational College. Welcome. So before we begin, I hope you remember that during our last class we discussed the parts. We discussed the PLC. Essentially, we went through what is a PLC, what it can do, why we should use it. So important to keep that in the record. Some of the types of PLCs that we find in the market today. So let's begin. By the end of this lesson, you should be able to identify the types of a PLC, and you should also be able to identify the parts of a PLC system. Those are the lesson objectives. So let's go right into it. So what is a PLC? Basically, we say that a PLC is a rugged computer used in industry. When we say a rugged computer, what we mean is a computer which is able to withstand abuse. You can note that in industry there is a lot. Industry is a hostile environment. We have dust, we have moisture, we have a lot of environmental factors. Also not forgetting that we have aspects like mechanical damage. Someone might be throwing a hammer around. So you need a computer which is not sensitive, which is a bit hardy. That's why we say it's a rugged computer. So as usual, when we talk about a computer, we look at the parts of an ordinary computer. So if PLC is a computer, what are the usual ordinary parts of a computer? Which brings us, so a computer is made up of input devices. Input devices are what you use to feed in information to the computer. We have the keyboard, the mouse, scanners. These are input devices. And then we have the output devices. Output devices are devices which give back information. You feed in data and then you get information. So type of output devices will have things like the screen, the monitor, will have printers, will have speakers. They output some, they give you back some, they give you feedback from inside the computer. Now next is the processor. The processor is the center of the computer. This is where you're processing. This is essentially what you're calling a computer. This is where the input you're giving it is being fed through the processor to give you the output. So the processor is the brain, is essentially the brain of this computer. So this is where the thinking occurs, this is where the logic occurs, this is where things are going on. So when we say the processor, you think about the brain of the computer, the think center of the computer. Finally, we have the memory. The memory, this is where data is stored. For us, we have a brain which can think and has storage at the same time. But for a computer, we have a separate memory, because the processor, it does the thinking, but it doesn't store information. So the memory in a computer is where the information is stored. The data you input is stored there. The information which is outputted to you is also stored there. So once we're done with that, we remember that a PLC is a computer in its basic form, right? So if it's a computer in its basic form, then it will have the same exact parts, making up the input, output, processor, and memory. We'll see that very shortly. And so, before we get into the parts of a PLC, we'll go through the types of PLCs. So we have two types of PLC. We have the unitary and we have the modular. The unitary PLC, this is a PLC which is sold as one component. Think about your phone, for example. You see, your phone has everything that you need. It has a screen, it has a processor, it has a memory, and you can't really add a lot to your phone. You can't add another screen, you can't add, you can expand your memory to some extent, but you can't change your RAM, there's a lot of things you can change on your phone. So there are PLCs which are like that. They are made with everything compact, nothing can be changed, nothing can be, made any different. So you have such. Next we have the modular PLCs. Modular PLCs are made by bringing together different components. Think about a lorry, you know. The same lorry can be used to make a bus, it can be used to make a truck, it can be used to make a dumper truck, it can be used to make an, you know, you can do a lot of things to a lorry depending on why you're buying it. You know, you can put a tanker behind it, it can transport oil, you can put a flatbed behind it, it can transport stones, you know. Modular PLC essentially means that I'll bring my input devices, I'll bring my output devices, I'll bring the memory that I need, and I'll bring the PLC, and I'll connect all of them together. You know, I'll build my PLC. Different from the unitary is that the unitary, you get one component, you get one, let's say, a package of PLC, and you use it like that. It's not, you can't expand it. But for a modular, you can build the parts that you need. If you need 10 outputs, you can build 10 outputs. If you need 10 inputs, you can build 10 inputs. It's a bit different from the unitary in that aspect. So next, we'll go to the parts of our PLC. So this is in essence what our lesson was about today, the parts of a PLC. So a PLC, we've said, is a computer. And we've said a computer has an input, output, storage, and processor. So we'll identify these parts on our PLC. We'll be able to see the difference of these parts on a PLC. So number one, we have the input devices. Input devices are more so things like sensors. You know, you have your sensors with you. You have all these feedback from the system. It's going to be an input. You know, these are things, your commands also, your commands. You want to command your system, yeah. So you're going to have a input. Input is where you put in your information. Is where the information from the system is flowing back into the system. So before we actually get into the processor, we have the power supply. The power supply is it feeds power to the different parts. We have various ratings for the power for the PLCs. There are PLCs which can use 12 volts, those which use 24 volts. It basically depends on the type. Yeah. Usually you find the very serious one using a lot of power because they have a lot of parts. So you have your power supply, and it feeds the system, it feeds the sensors, it feeds basically it does a lot, yeah? And then next we have the central processing unit. This is where your data, your information, it gets processed. You know, you can see that maybe this system is monitoring temperature. This is where your temperature information is read. You know, it is processed. It is say, okay, fine, the person said it should be 30 degrees, it is 24 degrees. And then now we have an output. So when, for example, take an example of temperature. Suppose you're having a system where you want to monitor temperature in a room, and if it is too cold, you turn on a heater. If it is too hot, you turn on a fan. So the CPU is where your input from the sensor, the temperature sensor, will be processed, and they will be able to check, is it below 30 or is it above 30? So if it is, you can take action. Now next, the action is usually out through the output module. The output module is then able to switch on devices. It can switch on the fan, it can switch on the heater, it can act like a relay, yeah? It can act like a relay of sorts. Finally, we have the programming device. The programming device is used to program. It is used to give the parameters for your PLC. That is why you're going to program and say, okay, fine. If the temperature is above 30, we want to turn on the fan. So the fan will be connected to output number 1. So switch on output number 1. We have temperature below 30. We want to turn on the heater. The heater is connected to output number 2. Turn on output number 2. That's where you're gonna do that programming. We'll talk more about how types of different programming modules. Now next, what is the use of the Octaisolator found in the PLC inputs and outputs? I don't know if you noticed it, but we had an Octaisolator. The Octaisolator, it is found, you can very well see here. Let me highlight it for you. The Octaisolator is found in between the inputs and the outputs. Now, the purpose of the Octaisolator is to prevent high voltages from interfering with your CPU, because here we're dealing with industrial systems, and every once in a while you get a short circuit, something somewhere will go wrong, and you want to protect your core systems. So if the inputs are going to get damaged, let them get damaged, and you can replace the inputs. Of course, this is only possible with modular PLCs, because even for the others, you can still have the same Octaisolator, but it will be a bit different. So you have your optical isolation, which is used to protect from voltage surges, overcharge, things like that. So next, we have an assignment which is due, and it is, what is the difference between active, passive, digital, and analog PLC inputs? So what is the difference between all these things? So what is an active input? What is a passive input? What is a digital input? What is a analog input? Now, during our next class, I will call upon you to present on how to present on that. Yeah. So that is it for today's lesson. I'm very grateful for your attendance. Please make sure you sign your attendance on the LMS, and I will see you during the next class. You can always feel free to ask questions through our WhatsApp group. Thank you very much. See you next time.